Hello everyone, welcome back to Neurospicy Nursing. Today is going to be a med math review. We're going to go over GTT per min, all of those drip rates. We have some units per hours, infusion rates, and some weight-based dosing as well. So let's go ahead and get right into it. So this first question, where we see it's talking about that IV drip rate, it has 1,000 mLs of normal saline that's going to be running over 8 hours, and our tubing has a drop factor of GTT per min. So when we talk about drop factors, don't forget that unless you have to solve for the drop factor, that they should always be given. Even though, it's just because different types of tubings will have different drop factors, right? So the first thing that we're going to have to do here is take our 8 hours and convert them into minutes. So to do that, you're going to do 8 times 60 to get you 480. Now set this up in whichever way is more comfortable for you. For me, doing that kind of dimensional analysis kind of mixed with desired over half makes more sense for me. But again, do what makes sense to you. After we get that in minutes, we're going to divide the amount of milliliters that we have, divide that by minutes to get our ml per minute. So we have 1,000 mLs. We're going to divide that by 480 minutes. That's going to give us 2.0833 mLs per min. After we get that number, we're going to multiply that 2.0833 by our drop factor, which is 15, and we should get 31.25. Now, don't forget, when we're doing drop factors, unless otherwise stated, you should always be rounding to the nearest whole number. So we have a 0.25 if from the 10th place from the 100th place to the 10th place, that would convert to a 3 in the 10th place because that is a 5. Remember, equals or greater than 5, you're going to round up. But then in that 10th place, because we're left with 3, you're going to round it to 31. It's not going to round up to 32 because that's not equal to or greater than 5. So the final answer for this first question is going to be 31 GTT per min. Now, for this second one, when we're doing this problem, it's going to be very similar to the last problem. Again, you're going to start with converting those 2 hours into minutes. So 2 times 60, that is 120 minutes. We're going to divide mLs by min again. This is also going to give us 2.833 ml per min. But since our drop factor is different this time, we're going to take that 2.0833 and multiply it by 60. And that is going to give us a GTT per min, or a drip rate of 125 GTT per min. So final answer is 125 GTT per min. All right, for this third problem, this is our heparin weight-based infusion. It's already in kilograms for us, which is awesome. We don't have to convert from pounds to kilograms. Don't forget that your ratio for that is 2.2 pounds is equal to 1 kilogram. So we're going to take this 18 units per kilogram per hour, and we're going to multiply that by our kilogram. Because remember, it's asking for the infusion rate, so don't get thrown off by the bolus. We're just focusing on the infusion here. So doing that 18 times that 72 is going to give us 1,296. And that will be the final answer for this problem. Looking at question number 4. We have 25,000 units in a 500 ml bag. To make it easier for myself, I like to do the amount of units per one singular ml. So I'm going to divide that 25,000 by 500, which would give me 50 units per ml. After I do that, I'm going to look where it says there's 1,200 units per hour, and I'm going to multiply across. And by multiplying across and doing that dimensional analysis, when you're putting the units on top for the 1,200 units divided by 1 hour, and you multiply the 1 ml by 50 units is going to be on top for 1/2 and at the bottom for the ml per unit. Those are going to cancel, and it's going to leave you with mLs in an hour for your final answer to be 24 mLs per hour. Using the 4-2-1 rule, and all just got their PTT tested, and the increase is at 2 units per kg per hour. So we're going to take those 2 units per kilogram per hour and multiply it by that 90 kilograms to get how many units we're increasing by. And then all we're going to do is add those 180 units that we're increasing by to that 1,000 units to get 1,180 units per hour as the new answer for this question of the new infusion rate. All right, so maintenance fluid doses. If you haven't seen these before, don't worry. It's very simple. There's kind of 2 different rules that you can see for this. There's the 4-3-2-1. There's also the 150-20, so it's just dependent on which one is easier for you to remember. But they basically amount kind of to the same thing, right? In this case, I said to use the 4-2-1 rule. What that means is for every first 10 kg the patient has, it's 4 mLs per kg per hour for fluid maintenance. For the next 10 kg, it's 2 mLs per kg per hour. And then for the remaining kg, it's 1 ml per kg per hour. So in order to do this, we're going to take the very first, because our patient is 22 kg, those very first 10, we're going to multiply that by 4 mLs per kilogram per hour to give us 40 mLs per hour. After we do that, those next 10 kilograms that this patient has, we're going to multiply that 10 kg by 2 ml per kg per hour, leaving us with 20 ml per kg per hour. And then for those remaining 2 pounds, what we're going to do is do 2 kg times 1 ml per hour. So now we have 40 ml per hour, 20 ml per hour, and 2 ml per hour using the 4-2-1 rule. And all you're going to do is add them up to get 40 plus 20 plus 2 kg, or plus 2. And that's going to equal 62 ml per hour. Now, if you're using that 150-20 rule, that gives you the daily amount. You can do the same thing, use the 150-20, and divide that by 24 hours, and you would get the same answer. Okay. For question number 7, our patient is ordered 5 micrograms per kilogram per minute of dopamine. It's already in kilograms. They weigh 68 kilograms. Our bag of dopamine has 400 milligrams and 250 mLs, and we have to find the ml per hour. So what we're going to do is take those milligrams and convert them into micrograms. 400 milligrams times 1,000 gives you your microgram doses. So that will be 400,000 micrograms that we're left with. After you get micrograms, divide your micrograms by your ml, so your 400,000 that you now have, divide that by 250, and you're going to get 1,600 micrograms per ml. So in 1 milliliter, you have 1,600 micrograms. After you get there, we're going to find our ordered dose in microgram per minute. So you have 5 micrograms per kg per minute. We're going to multiply that by our 68 kilograms, and you're going to get 340 micrograms per minute. After you get that 340 micrograms per minute, you're going to multiply that by that 1 ml over 1,600 micrograms, and that's going to leave you with 0.2125 milliliters per minute. After we have the milliliters per minute, we're going to have to convert this into milliliters per hour. So that 0.2125, we're going to multiply that by 60, and you're going to get 12.75 milliliters per hour. Now, if we're rounding up to the nearest whole number, it's going to be 13 mLs per hour, because you have a 0.75. Both of those are greater or equal to 5, so you're going to round up, and you'll be rounding up to 13. All right, for this dilution problem, we're given an order of 2 milligrams of morphine IV. Our vial contains 10 milligrams per ml. And once it's diluted, we have 5 mLs. So we have to figure out how many mLs we're going to administer, right? So even though our dilution is changing the total volume of our morphine, right? Our dosage, our milligram, is going to stay the same. So we just need to figure out how many mLs is going to be equal to 2 milligrams with the new concentration that we have. So if we have 10 milligrams per ml, and there's 2 milligrams in X amount of mLs, X is going to be equal to 2 divided by 10. It's like 2 milligrams divided by 10 milligrams per ml. So that would mean that we have 0.2 ml where we have 2 milligrams. Now that we know that 2 milligrams is in 0.2 mLs for that first dilution, we are going to figure out based on the concentration for that 5 ml. But since we know to do this, we're going to multiply right by that 5 ml. We would give the entire, since we're diluting it in the 5 ml, we're going to give that entire 5 ml. Because we are diluting that 2 milligrams into the 5 mLs. So we're pushing 5 mLs because we have diluted those 2 milligrams in that 5. We just know that we added an extra 0.2 mLs to that 5 milliliters. Hopefully that makes sense. Okay, So for this next question, we have 15 milligrams per hour that have been ordered. Our bag is 50 milligrams in 250 mLs, and we have to find milliliters per hour. So we're going to do 50 milligrams divided by 250 mLs to figure out how many milligrams are in 1 ml. So in this case, it's going to be 0.2 milligrams per ml. After we get there, we're going to multiply those 15 milligrams an hour times 1 ml over 0.2 milligrams. Because remember, in 1 ml, there's 0.2 milligrams. That's going to allow the milligrams to cancel out, so we're left with mLs on top and hours at the bottom. And when you're multiplying across, it's going to give you 75 mLs per hour. So that's your final answer. For this reconstitution question, we're giving 100 milligrams per ml. After reconstituting, our order is going to be 350 milligrams. We have to figure out how many mLs we're going to draw up. So we know that we have 100 milligrams per ml, and we have to draw up 350. So do 350 milligrams divided by 100 milligrams per ml, and you're left with 3.5 mLs that you have to draw up. And that is all on today's Med Math review. If you have any questions, leave any comments. Don't forget to like, share, and subscribe. And I will see you guys in the next Med Math review. If this was helpful, let me know. If I need to do a little bit, change the way I explain things for you guys, also let me know. Any feedback is really helpful. But have a wonderful day. Bye.